Hey guys, we're going to look at rotational motion just a little bit. First of all, here I have my wheel that's just free to rotate here, and I have two flags basically, okay, that I've marked. Hopefully they'll stay in this position, but I'm sure you would agree that my two flags are this different radius away from the center here, or the axis of rotation. Now, a lot of people get angular velocity or rotational speed and linear speed mixed up. So your rotational speed, from your notes, it says rotations over some amount of time. Now, when we look at rotations, we look at the angle, okay, that an object moves, okay, or the angle through which something rotates, and that's why it's called angular speed in some cases, over some amount of time. Now, if we look at these two flags right now, you would agree that they're both at about 90 degrees. Well, if I rotate them here, there's both at about 45 degrees. If I rotate them here, they're at 0 degrees. So if you look, they are always going to be at the same angular position, the same angle at every point. So that means that no matter how much time goes by, they are going to have the same angular displacement. And if they go the same angular displacement in the same amount of time, they must have the same rotational speed or angular speed. And that is because even though they're at different radius, they're staying with the same angular position, okay, to each other. Now, linear velocity is what's different. So linear velocity depends on your radius. And you guys have experienced this. If you are on the outside of a track, okay, and you're trying to keep up with somebody, by golly, you have to run a little faster to keep up with them, or you can't stay on the same I want to say radius there, but you can't stay on the same, you can't stay beside them, basically. If these were two runners, okay, you would have to run really fast on the outside of the track to keep up with the person closer to the inside of the track, because you have to go more distance. Imagine that I had a string, and as I rotated this, I rolled a string with it. Well, if we were to do that for one or two rotations, or even any rotation, we would see that there is a much larger string for this one than there is for this one. So that means that this has a larger circumference, okay? Since it has a larger circumference and the string is longer, then that means we covered more distance. When you cover more distance in the same amount of time, you have a larger speed. So this is called linear speed or tangential speed when we're talking about the actual distance that those flags cover, okay? This distance is based off of the circumference. Okay. All right. Hope that makes it clear if it wasn't before. So y'all have a good day.